Okay. Well, these equations, the one called a stress-strain relation in three-dimensional case, and I will add one more worksheet here, okay, and then copy this. Let's try to enter these equations. So that how many equations we have here? This is how many equations? 6 equations. How many stress? 6. How many strain? 6. So totally 12 unknowns and 6 equations. So to solve the rest of them, we need to have 6 terms are given and the other 6 can be calculated. Okay, keep that in mind. Now I'm trying to enter these equations in Excel and please take a look at it, how to do that. Okay, you can see here left hand side, you see the 6 by 6, okay, this much, and 6 by 6. I will have this one. This 6 by 6 will represent this 6 by 6. To do so, how many parameter material property we have? Well, we have a Young's modulus, Poisson's ratio, and shear stiffness. So let's define E and actually nu, not the V, but we're gonna use that one, nu and G. So this one, let's say we're gonna enter value for Young's modulus E and mu and G. So to give this one as a name, we give a name E. We give a name V here. Oops. Here on the, this is the corner where we define name. Okay. 그러면 이제부터 자 봐요. equal E divide by 2. 이케이션 기억나요? 2 times 1 plus mu, right? 하고 여기에 뭐 100, 0.3 하면은 자동으로 계산돼요. The good thing is that we use this symbol as we learn. That's the key point. 이게 만약에 엑셀 여러분 썼지만은 이게 뭐예요? 주소가 D2죠. D2 이거는 뭐야? D3 이거를 D2 나누기 D3 이렇게 하면은 우리가 나중에 팔로우를 못해요. Imagine so many equation is very difficult to follow, but this way is very easy to follow, and you can find a formulas. And from here, this term, the value comes from here, and value comes from here. Okay, now here, just to follow this one, equal 1 over E what? Okay, 이게 뭐예요? 여기 수식대로 그냥 엔터했죠. 1 over E. 그래서 이게 저절로 계산이 됐어요. 그 다음에 여기 copy copy. 다 똑같죠, 이거는? 요 수식을 잘 보세요. 여기가 수식 나오는 데죠. 그 다음에 여기는 뭐예요? 마이너스 mu divide by e. 맞죠? 그래서 copy, 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 copy. 그 다음에 여기는 전부 다 뭐예요? 0. 자, 그 다음에 요 다이고널 텀이 하나, 요 놈이 뭐예요? 1 over 2g. 맞아요? 맞잖아? 이렇게 해줘야 돼? 같은 거죠? 예? Okay. 그래서 the point is that whatever value we have, say 200, this value will automatically update it. And so let's say this one, I will color them in blue, means that this is the independent. Now this is the equations, and I will color them as red, just to indicate what are the dependents. Well, here we don't need it, actually. So this is the equation. Now, let's say we have a stress. Let's call this much is the stress. And stress is a 1, 0, 0, 0, 0, 0, 0. That is a stress. And now we want to calculate a strain, how much the strain will have. To do so, what do we need to do? We need to multiply this and that. 그렇죠? 이놈을 어떻게 multiply 할까? First, we need to call this one as the strain. 이게 셀을 하나만 부를 수도 있고 이렇게 레인지로 벡터를 이름을 줄 수도 있어요. 그 다음에 요 놈을 이 전체를 또 이름을 줄 수가 있어요. 이걸 뭐라고 이름을 줄까? 이거는 스티프니스의 역수예요. So it is some often called compliance. 뭐라고 부를까? S라고 부릅시다. S. Now this one, let's call, what is it called? Stress. 그래서 잘 봐요. 스트레스는 뭐예요? 이놈 곱하기 저놈이죠. equal matrix multiplications S matrix times strain. Then this matrix multiply 이거가 된 거예요. 그래서 여기에 뭐 2를 곱한다, 어떤 any value you enter. 하면 이 stress is automatically calculate. Say, I want you to pay attention that 1, 0, 0, 0, 0, 0. What is this state? We apply only extraction and extension, right? And this is what? Strain. Strain, you can see that epsilon xx, and this is what? Epsilon yy, and this epsilon zz. So this is a plus, and that is a minus, minus, and look at that. How much the ratio between this epsilon xx and yy? Exactly Poisson's ratio effect, right? There is a minus and minus. Now you can very interestingly enter 1 and 1. You apply this, that, and that at the same time, then you can see how much strain will have. They will be, of course, the same, right? Because we apply everywhere the same strain and the same stress. Now, what if, let's go back and see. 그런데 자, 지금은 어땠어요? strain and 내가 이거 S라고 이렇게 부를게요. 이렇게 뭐를 지금 한 거예요? 바로 요거를 한 겁니다. Okay, so S strain is the 6 and S is a 6 by 6 and sigma is like that. But what if we apply strain and calculate the stress in the other way? Meaning strain, stress, stiffness, and strain. To calculate this C matrix, what is the C? C will be simply S inverse matrix, right? So using that one, now this can be given, strain is given, and how much the stress would be needed to generate this much strain, right? So let's try to that one. So how to make inverse? How to make the inverse? Well, let's select this much and 6 by 6 and equal matrix inverse of S matrix. This is the inverse of this 6 by 6 matrix. So this is called, we call what? C matrix. Okay. C is a very special character. We're not allowed to use C as a name. C mesh라고 부릅시다. 그래서 우리가 거꾸로 let's call this one as what is a stress. Yeah. And now this one, try to calculate it. What did I do? This one is what? Oops, made a mistake, huh? This should be strain, right? 내가 이름을 잘못 넣었죠? 맞아요? 이게 첫 번째 거잖아요. 네? 이게 뭐예요? S 매트릭스죠? I'm sorry, I made a mistake. 네임을 잘못했죠. 이게 뭐야 돼요? 네, 스트레스. 자, 이름을 다시 지우려면은 가서 스트레스 어디냐? 여기 있네요. 요놈 지워버립시다. And then let's rename here. This is what? Stress. And this one is the strain. Strain. 그렇죠. Okay. Thank you. So this one, let's call stress. So this one, I will just write down here, stress and strain. Okay. Let's try to have a real material value, Young's modulus of the steel. What's the Young's modulus? 200 gigapascal. What is a giga? 10 to the 9, right? So this is the real gigapascal. And so Poisson's ratio is 0.3, and this is the shear modulus. And now the stress, 1 Pascal, 1 Pascal, 1 Pascal. Take a look at how small strain we have. But let's say we apply 1 megapascal. Megapascal is what? 10 to the 6. And strains are really still small. Okay, let's apply 1 gigapascal. Then strain is what? 0.002 means 0.2%. Whenever you look at, you need to better visualize them. Okay, 0.2%. That is the is about realistic value. Anyhow, this is a strain, and this is what inverse of this C matrix. And let's try to recalculate the strain and the stress. So equal net, now C net times strain. Okay, what I did is that this one is the inverse, and this one is the starting. I assign number. Blue, let's say blue is the input, okay, and this is what? Output. I will call red. So whatever value we have that much strain. And this one, and then from this is the strain, and we multiply C and recalculate the sigma. That is the recalculate the sigma. Of course, they should be the same, right? Of course, they should be the same. And as you can see that. Okay, we can double check this test. So whenever we have a strains are given, and we can have, this is the stress. So let's call this one. Let's say this is a strain. But I don't wanna give a name, same name. Okay, we can give a name, this one. And now this one, I will change the color, blue, and this one has been now a red. 그래서 지금 무엇을 한 거냐? 이게 지금 스트레스가 주어졌을 때는 이놈을 곱하면 스트레인이 계산되죠. 스트레인이 주어졌을 때 이놈을 곱해서 뭐가 계산돼요? 스트레스가 계산된다는 뭐 간단한 얘기예요. One of the function you can use is simply a matrix multiplication. 이 매트릭스가 엑셀이 인버스 매트릭스를 아주 잘해요. 얼마였어? 한 100, 200 물어봤어? 백바이백을 오케이 그냥 50 by 50 빠납시다. This one is 50 by 50 and say equal random 아무 밸류나 랜덤이 가로를 열어야 되겠네. Thank you. 랜덤이 이렇게 generation 돼. 랜덤 하면은 it's just arbitrary select from 0 to 1 and copy and here so we got the all random number 50 by 50 and then we inverse this matrix well, just say try. And here, 매트릭스를 인버스 할 때는 항상 사이즈를 해놓고 이퀄 하고요. M 인버스 가로 열고 닫고 가로 열고 try 하고요. 매트릭스 네임 쓰고 여러분들이 못 보지만은 Shift하고 컨트롤 키를 누르고 엔터를 쳐야 돼요. 그냥 엔터 치면 안 돼요. 어쨌든 이게 위 매트릭스의 인버스예요. 지금 50 by 50만 했지만은 뭐 100 by 100, 200 by 뭐 no problem. 그래서 여러분들이 그 매트릭스 인버스를 한 뭐 포트란 프로그램도 짤 수 있고 뭐 여러 가지 할 수 있지만은 I'm trying to demonstrate how powerful this Excel can be and you can do many things. 또 보면은 비주얼 베이직 코드를 짜서 이 매크로를 할 수가 있어요. Like a Fortran or C, any languages similar to any language you can develop. 그거 하려면 여기 보면은 옵션에다가 추가 기능에 일단 분석 도구 이거 있으면 좋고요. 이게 처음에는 숨겨져 있습니다. 여기 보면은 요거 비주얼 베이직 들어갔고요. And then there is a option, and there is 이 체크를 해줘야 여기에 개발 도구라는 게 떠요. 한글로 돼 있어 잘 말로 못해. 개발 도구를 뜨면은 여기에 비주얼 베이직이 나와요. 그 비주얼 베이직 딱 누르면은 여러분들이 이제 모듈이라는 거를 이제 해서 you can develop 여기 보면은 모듈 하면은 여기서부터 이제 여러 가지 그 여러분들이 프로그램, 포트램 프로그램 C 짜듯이 쫙 짤 수가 있어요. 그 짠 놈을 엑셀에서 go back to Excel 여기서 이제 이놈을 뭐 해라, 계산해라, 뭐 여러 가지 하는 거를 할 수가 있어요. 오케이? 여기 보면은 스퀘어 루트라는 게 있죠, 펑션이. 이것처럼 여러분들이 you can create your own function, that is a function, or you can create your own subroutine, and you can generate all values. So it can do exactly same as you used to do in other language developers. Okay, so anyhow, what I want to demonstrate here is that we simply make this table and then try to give some numbers and calculate I remember a long time ago, we tried to calculate, for example, say we have a steel bar, okay? Imagine we have a steel bar, and imagine this steel bar is the 1 meter long, and imagine we have this is the 0.1 or 10 centimeters, 1 centimeters, and we apply force 100 kilogram. 우리가 이렇게 매달려 있는 것처럼 한번 힘을 가하면은 let's say how much strain we have. 얼마만큼 이 델타가 늘어나는가를 한번 realistic하게 한번 apply 해봅시다. Now 100 kilogram is the in terms of a Newton we call 1000 or 980 Newton, right? You need to multiply G, so 1000 Newton, and stress wise the area will be 1 centimeter means 0.01 times 0.01, right? So this will be 10 to the minus 4. And stress-wise, now we have a force divided by A. The force will be 1000 divided by A. That will be 10 to the 7, Pascal, right? 10 to the 7 Pascal. And this is the steel. And let's say here, the two steel bar, 200 gigapascal, this and that, and now stress. How much was the stress? 10 to the 7, right? 10 to the 7, only 10 to the 7 is much, and then others are all 0, 0. And this is the strain you would observe. Very small. Now, how to calculate deformation? Well, we simply need to apply because the what we calculate was, say this is the L, strain is delta over L, right? So delta will be epsilon times L. The L equal 1 meter, and strain times 1, and this will be a delta. 단위가 뭐예요? 미터예요. 네? 미터. 그러니까 미터, 그러니까 델타가 equal 이놈 곱하기 length 랭스가 1m니까 델타가 요거고 요놈을 1000으로 나눌까요? 그럼 뭐예요? 1000이 아니라 1000으로 곱할까요? 밀리미터로 보이기 위해서 0.5mm. 여러분들이 1m 스틸바에 여러분들이 매달려봤자 0.05mm밖에 안 늘어나요. 우리가 얼마나 가벼운지 알겠죠? Okay, well, this way we understand the stress strain in three-dimensional case. And imagine that there is another term is called thermal strain. Thermal strain이 뭐냐? Thermal strain, when we have a temperatures, let's say we have a body, just like a body, and then we increase the delta T. We increase the temperature. No stress, we don't apply any stress, but only temperature. Then this one extend, everywhere is extend. So epsilon XX extend, there is a ratio, is called alpha, and epsilon Y, epsilon ZZ, there is alpha and alpha. The alpha is what? Very important material property we call CTE, coefficient of thermal extension. Coefficient of thermal expansion, CTE, and no shear terms. And so this is the final equation when we have stress and temperature all together. And this is the final strain. It has to be a delta T and stress. And here is the alpha. Alpha is the CTE. That's all material properties. Okay. So that is the important 6 equations. And look at that. Alpha is the value like a 10 to the minus 6, very small, 10 to the minus 6, and still it's about 10 to the minus 6. And copper about 15, 16, and rubber is like that. Okay, so that is what I want to cover this week. And okay, I will move. Last one is a homework. Homework number what? Okay, 4.1, let's say sigma x, sigma yy, and sigma zz equal all given as the 1 and delta t equals 0, where calculate all strain component. Okay, how many components? 6 components. This means others are 0. Okay, other stress are 0. Now pay attention here. Sigma xx equal 1 and epsilon yy equals 0, epsilon zz equals 0, and delta t equals 0, and calculate epsilon xx and sigma yy and sigma zz and other strain, shear strain and shear stress are all 0 because of no coupling term. Now 4.3, epsilon xx equals 0, epsilon yy equals 0, epsilon zz equals 0, and delta t is the 100 Celsius. This is the, okay, by the way, they are all still, okay? You can get the material property. And now you calculate sigma xx, sigma yy, and sigma zz. I mean, here, up to here, all sigma ij and it's, well, xy and sigma yz and sigma z zx, they are all same. Okay, all 0. Sorry, all 0. I will put these things here. 우리가 이 스틸 바를요, 스틸 바를 여기다가 벽 사이다가 딱 껴놨어요. 이렇게 벽 사이에다 딱 껴놓고 뭐 움직이지 마라. So this steel bar is not allowed deform, constraint. 그런 다음에 어떻게 했어요? 온도를 올렸어요. 온도를 100도씩. 그러면 얘가 막 늘어나려고 하죠. 근데 못 늘어나려고 했으니까 뭐가 생겨요? 여기 엄청난 이 발력, 힘이 생기겠죠. That we call reaction force. And how much reaction force will it have? A cross section A is I'm sorry. A is the 1 centimeter by 1 centimeters. And the length is the 1 meter. Cross section is 1 centimeter by 1 centimeter. Okay, that's the homework. Yes. Good questions. Sigma y and sigma z equal 0. What does it mean? Y is a freely expand. 이해돼요? 안 돼요? 왜 안 될까? 그러니까 여기에 기름칠을 해놨어. 기름칠. 여기에도 기름칠을 해놨다고. 그럼 어떻게 돼? Y랑 X는 그냥 자유롭게 늘어나죠. Y하고 Z. 근데 X만 못 늘어나는 거예요. Okay, this is X direction. And Y and Z, no restriction. Only X direction. So freely expand in Y and Z, only constraint in X direction, and how much a reaction force, of course. 어느 방향으로? X 방향으로. 이해돼요? 네, 글씨도 잘 못 써, 깨끗하지 않은데. It's clear. Is that okay? Okay. So this is a very important homework, and these are one of the question in midterm. midterm도 이렇게 나와요. Well, you don't use Excel, but it's good to use Excel. 근데 Excel은 이게 지금은 쓰기가 힘들어요. 왜냐하면은 if you look at this one, 시그마 XX와 입실론 YY ZZ가 주어졌어요. 그 다음에 나머지 입실론 XX, 시그마 YY하고 ZZ를 구하는 거예요. 이게 무슨 말일까? 여기서 보면은 이놈이 주어지고 요놈이 주어지고 요놈을 구하고 요놈을 구하는 거예요. 맞죠? 엑셀 가지고 이렇게 하기가 지금은 힘들어요. 오히려 손으로 이렇게 팔로우 하는 게 더 낫겠죠? 오케이? 오케이. 오늘 수업 여기까지 하고 다음 주에 봅시다. 매주 물어. 화요일 밤